Okay, this is question number 3 from the 2019 AP exam. And for this question, the calculator is not allowed, so don't use your calculator. You do not have to simplify though, so if there's a question that you're not sure of, like adding or subtracting something, you can just leave it. So here we have a picture of a graph, and this is a graph of f. It's a continuous function. And it says it goes from -6 to 5, but we actually only have a picture of the graph from -2 to 5. The figure above shows a portion of the graph of f consisting of 2 line segments and a quarter of a circle centered at the point 5, 3. It is known that the point 3, 3 minus root 5 is also on the graph. Okay, so part A says, if the integral from -6 to 5 is 7, find the value of the integral from -6 to 2. Show the work that leads to your answer. So I'm going to mark up the graph up here so I have like a little list here. So they tell us that the integral from -6 to 5, so they give us the whole value is 7. So I'm going to write that down. I want to find the value from -6 to -2. So if I can find this value, if I subtract that from 7, that'll give me my missing part over here. So I'm going to mark this, -6 to -2. This is a question. We don't know what that is. But I know the whole distance is 7. So I'm going to find this value. So here we have an integral, or we have a graph, and we're going to find an integral. So the integral from a graph is the area. So I'm just going to figure out the area from -2 to 5, subtract that from 7, and that'll give me my missing area over here. So first off, just looking at this graph here, I've got this triangle here and this triangle here. This area is a, let's see, 1/2 base times height. This area would be 1/2. Down here, this area would be -1/2. So they actually cancel each other out. That's 0. I can say the same thing for this area here and this area here. If I solve this though, this would be 1/2 base, 1/2 times the height, which would be 1. So this would be -1/4 down here, and this would be +1/4. I've got this next shape here. This is a trapezoid. So I'm going to use my trapezoid formula. 1/2 base 1, which is 1, plus base 2, which is 3. The distance in between is 1. So that gives me 2. So far all of these cancel and give me 0. This is 2. So now I need this shape right in here. This is kind of a funky shape because it's like the outside of a partial circle. So I bet if I find the area of this partial circle and subtract the area of the square, I can figure out this missing section. So this partial circle, this is a quarter of a circle. This is 1/4 pi r squared. The radius of this circle is 3. So 1/4 pi, 3 squared would be 9. So this area would be 9/4 pi. Now the area of the square, base times height, so this would be 3 by 3. So that would be 9. So this area would be 9 minus 9 pi over 4. Okay, so let's add these up. So I've got 0 and 0, I've got 2, and then the 9 minus 9 pi over 4. So the integral from that's -2 to 5 of f of x dx is 2 plus the 9, so 11 plus, minus 9 pi over 4. So that's just this section. The whole thing is 7, so I'm going to take 7 and subtract the 11 minus 9 pi over 4. And I can leave it like that, right? You don't have to simplify. Oops, let me move this up a little bit, sorry. Or we can write it, if I distribute that negative, 7 minus 11, negative 4 plus 9 pi over 4. So for this question, it just says show your work. So you want to make sure you get full credit. Write down everything that you did. I kind of put it up in the graph here, but if they give you a box to show your work, make sure you put everything in the box. Okay, so let's go on to part B. Part B says, evaluate the integral from 3 to 5 of 2f prime of x plus 4 dx. So I'm going to write this down. And I'm going to take the integral. So first step when we take the integral, we're just going to work from left to right. The integral of f prime would just be f, and I'm going to bring down that constant, so 2f of x, plus I'm going to add 1, so 4x, and we're going to evaluate this from 3 to 5. So in our rules for integration, we plug in the top number first. So 2 times f of 5 plus 4 minus, now we're going to plug in the 3, 2 times f of 3. Whoops, I forgot to multiply the 4 by the x there, so 4 times 5 should be right there, plus 4 times the 3 over here. Okay, so we need f of 5 and we need f of 3, and that we can use right from the graph that I made really messy up here. So f of 5, if I look at my graph, is 0, so I'm going to plug that in down here. 2 times 0 plus 4 times 5 minus 2 times f of 3. So if I look at my graph, f of 3 is some weird spot right here, but if I notice in the directions, it tells us what 3 is. 3 is 3 minus root 5. Plus 12. Now, in the AP exam, we do not have to simplify, so I would stop there. Don't go any further. You don't want to risk losing points because you didn't simplify correctly. Okay, so let's go down to part C next. Part C says the function g is given by g of x equals the integral from -2 to x of f of t dt. Find the absolute max on the interval from -2 to 5. Justify your answer. Okay, so a max comes from the first derivative. So I'm actually going to take the derivative of this. I want g prime of x. When we take the derivative of an integral, remember they just cancel right out and the x goes in place of the t. So f of x dx. And, oops, I don't need a dx, sorry, get rid of that. We take our derivative and we're going to set it equal to 0. So we find a max by finding the derivative and setting it equal to 0. So now we're going to solve. So I want to know where f of x equals 0. Well, I have a graph of f of x. So let's see. My graph equals 0. I'm going to use a different color. F of x equals 0 here, here, and here. So I'm going to write those down. -1, and this would be 1/2, and 5. We also could have maxes and mins at endpoints, so I also want to include -2 in my list. And the question says we're going to actually find the max. So I want to find which one of these is the highest point. So I've got a formula here. I'm going to set up a little table, X and Y chart. I'm going to make a list of my points here. And my formula for g of x is the integral from -2 to x. So for this first one, I'm going to find the integral from -2 to -1 of f of x dx. So that's just the area between -2 and -1. So if I look up at my graph, the area from -2 to -1, I already labeled it, is 1/2. So I saved myself some time there. Next one, I'm going to take the integral from -2 to 1/2. So looking at my graph here, -2 to 1/2. So that would be 0. -2 to 0 is 0. Plus 1/2, this little area is -1/4. Third one, I'm going to go from -2 to 5. So I already know that whole area. That's the big area. And we got that in letter A, I think, right? 11 minus 9 pi over 4. And then -2, that would be the integral from -2 to -2. That's one of our properties of integrals. It's the same, so that area is just going to be 0. So we want to find the max. Well, I know it can't be the 0 or the negative. It's got to be the 1/2 or the 11 minus 9 pi over 4, which this is definitely bigger. So my max occurs at f of 5. Oops, sorry, not f. We're doing g. G of 5, which is 11 minus 9 pi over 4. Final answer. Okay, last part, part B. Sorry, part D. We got a limit to find. So we're going to find the limit as x approaches 1. Now, first thing we do with a limit is we try to plug it in and see if we get an answer. So I'm going to plug 1 in. If we get an answer, then we're all good. If not, we have to try something else. We can use L'Hopital's rule by taking the derivative of the top and the bottom and then plugging in. So I'm going to evaluate. Let's see if we get an answer. We just can't get 0 over 0. So 10 to the first is 10 minus 3, f prime of 1. So I got to go back to my graph. The derivative at 1, which is the slope. So 1 is a straight line here. The slope of this straight line looks like we're going up 2 over 1. So the slope of that line is 2. So I'm going to plug in 2 for f prime of 1. Over f of 1, got to go back to my graph. F of 1 is right here, and that's 1. So my height at 1 is 1. And then this one you have to know, arctangent of 1. So think about your unit circle. Tangent is equal to 1, where sine and cosine are the same. So at this point right here, root 2 over 2, root 2 over 2, tangent would be 1, and the name of that point is 45 degrees, or pi over 4. We always use radians on the AP exam, though. You don't have to simplify, so you can stop right there, and you're done. I wouldn't go any further, because you don't want to risk making a mistake and losing credit. So let's look at the point breakdown of this question. Part A, 3 points. So you get 1 point for, it looks like, and knowing that the 2 parts equal the whole. So you want to make sure you write down what you got for the 2 parts. Though you get a point for finding that second part correctly. So that was like the 11 plus 9 pi over 4. And then 1 point for subtracting and getting the answer. Letter B, 2 points for this one. So 1 point for the fundamental theorem of calculus. That means taking the integral and doing your top minus bottom. And then 1 point for the correct solution. And then part C. This one was worth 3 points. So this is, first point is for remembering that finding a max means you have to take the derivative and set it equal to 0. Finding your candidates, meaning like where is it equal to 0, and then finding the answer. And then D was just 1 point because that was just a plugging in question and you find the answer. So that concludes our explanation of the second FRQ.